It's an equilateral triangle. Now let's assume that, let's just arbitrarily make this one unit length. If that's 1 unit length, what then is this whole thing? 2. If it's equilateral, what is this? 2 as well. Okay, so now I know that in my original triangle I have 1 and I have 2. Can you figure out what this length is? Using the Pythagorean theorem? Yeah, it's the square root of 3. Now, if I want the sine of 30 degrees, the sine of 30 degrees is opposite divided by hypotenuse. It's 1/2. The ratio is 1/2. Did you have it right? Okay, good. Okay. So, that now, let's see, I was looking at, if I take the beginning of the interval here, I get 1 divided by sine of pi divided by x, or the sine of 1 divided by sine of 30 degrees, or 1 divided by 1/2, which is equal to 2. Okay? So on the lower end of the interval, my cosecant value is how much? 2. Okay. What on the other side of this? Okay, so now we have to do the whole thing again, and let's see if I can, okay, let's see if I can put it down here now. We have cosecant, and now we're going to have pi times 5 divided by 6. That's going to be 1 divided by the sine of 5 pi divided by 6. Actually, what we need to do is probably, what's your question, Liz? Where's the 5?
Yeah, what, from the second equation?
No, from the other end of the interval, okay? Because this is only relevant in the interval from 1 to 5. So we're looking at the endpoints now. So we looked at 1. What's the cosecant when the input is 1? And now we're looking at the cosecant when the input is 5. Okay? So, let's see. We do that. Now we have to look at what is the sine of 5 pi divided by 6. Well, let's go back to our unit circle. And remember, we are always talking about an angle in the first quadrant, but we can use the angles in the first quadrant as reference angles for other quadrants. So if I have an angle of 5 pi divided by 6, where is its terminal side? Now let's see, this is 0, and this is pi, right? And this is pi divided by 2, and this would be 3 pi divided by 2, and wrap it all the way around, so this is also 2 pi over here, okay? So where's the terminal side of the angle that starts here and opens counterclockwise, 5 pi divided by 6 in the second quadrant? So it opens up to something over here, let's say. Okay, so that's our angle, 5 pi divided by 6. Now, in order to evaluate the angle 5 pi divided by 6, we're going to evaluate instead another angle. Because I know that a point here, it has another point over in the first quadrant that has the exact same output value. So if I can find a point over here, there, let's say that's it. So over here now, I've got cosine theta, and I have sine theta. Remember that? Okay. And I've got now that I have opened this up so that it's at 5 pi divided by 6. So over here, actually, I should have put this over here. I'm going to go back and correct that, because this is sine theta, cosine theta. What is this? It's not, yeah, it'd be the opposite of cosine. So let's see if I can very easily, there we go, it's going to work. I'm going to put a negative in there, negative cosine, because it's the opposite input value but the same output value as we go along. So what we're going to do, as you recall from your geometry or your trig class, we're going to evaluate an angle here called alpha. And alpha is now this angle here, which is equivalent to this angle over here. So the reference angle is going to be alpha. It's equivalent because the sine value is the same here at this point as it is over on this point. Okay, so if I can evaluate this, so what is alpha? It's not 5 pi divided by 6, it's because I'm going to take the difference between pi and 5 pi divided by 6, and it's the same thing as pi divided by 6. Okay, so if I can evaluate this angle, I have then the same thing. So what do we have? Do we know what that is? Should be about the same thing we had before, isn't it? Didn't we have pi divided by 6 up? Okay, so this is the same thing. It's equal to 2. Okay. Now, on a piecewise defined function, the question we haven't asked ourselves is, where is this undefined? Okay? If by chance it's undefined in this interval, we have a problem because it will be discontinuous in that interval. If by chance this is continuous in this interval, and we know that this linear function, this horizontal line, is continuous everywhere, so of course it's continuous in x less than 1 and x greater than 5, then this whole function is continuous because it never has any gaps. This is less than, but this is less than or equal to. So we know that when the input is 1, cosecant of pi times 2, pi times 1 divided by 6 is equal to 2, which is the same value as this. So these have the same value when the input is 1. It also has the same value when the input is 5. Okay, so now the question is cosecant pi x divided by 6, is it discontinuous in this interval at all? How will you evaluate that? Check our time here. Oh, we got plenty of time. Okay, and let's see if this is still active here. Can I pull that? Yep, there it is. Okay, so again, just a little reminder as you're thinking about my question. The question is cosecant pi x divided by 6, is it continuous in this interval? Or where, in fact, is it discontinuous? So let's see. Cosecant pi x divided by 6. We said it's the same thing as 1 divided by the sine of pi x divided by 6. Let's see, what else do we know? On the unit circle, is sine ever undefined? No. But it's in the denominator. In the denominator, we got to be careful about what? So where is sine value equal to 0? Here at 0, okay, so we have cosine theta and 0. Over here at pi, we have the opposite of cosine theta and 0. Is sine, is it undefined anyplace else? How about at, let's see, if I wrap this around completely, this would then be at 3 pi. So it is discontinuous at 3 pi. Okay, and if I come around here, then it's discontinuous at 4 pi. So that's where we get the multiple discontinuities. You know, when we look at that graph, we have those series of, you know, this and so forth, because these occur where? This is going to be at 0, okay, and the next one is, and I don't know if I have these correctly as up and down, so we'll go back and look at it, but the other one's going to be where? Pi, and the other one's going to be where? 2 pi, and so on and so forth. Now, we're going to be in the interval from 1 to 5. So if I have 1 as pi divided by 6, okay, that's over here, pi divided by 6. Do we agree it's in the first quadrant? And I have the other one at 5 pi divided by 6. And the only inputs I can use would be from pi divided by 6 to 5 pi divided by 6. Any chance that we're going to have a discontinuity? No, because we're not at 0, and we're not. Well, what about down here? Isn't this less than? Don't we get the 0 down here? Isn't 0 less than 1? But what do we have to consider? 0 is less than 1. Sine of pi divided by 6 is, or sine pi x divided by 6 is equal to 0. Okay, well, let's see here. Is that useful in this part of this piece? It's not our concern. Okay, none of our concern. We're only concerned in the interval from 1 to 5. Okay, so now, we did all this stuff analytically. I got to see a picture of it. Take your inspires. And let's see here. We got time, okay. Let's look at a picture of this. So how are we going to get a picture of this function? You see, that one problem is much more involved than what we first thought. It's a nice little piecewise defined function, but, you know, have we even talked about continuity? Well, kind of. We're going to get back to those 3 criteria, though, after we see a picture of this. Okay. Okay, let's just go to a graph page. Now the question is, how will you put this function into your Inspire? It's got to be piecewise. Wouldn't it be nice if there was some template that we could use that would look just like what we have on the piece of paper? Wouldn't that be gorgeous? Well, let's see if it does. On the black model, you've got templates right here. This little button I'm circling is the templates. If you're on the gray model, you're going to have to do control on multiplication. Control on multiplication. I have it highlighted because I used it in the class yesterday or Tuesday. Right here. This is our piecewise defined function, 2 pieces. Now, what if you have more than 2 pieces? You use the next one over. The next one over can allow you to use as many pieces as you need. But we only need 2, so we're going to use the 2-piece one. There we go. Now, we're going to have to find our cosecant. I will tell you on the black model, if you go to the button that says trig, you've got a cosecant. Okay, a little easier. But what if you're on the gray model? We don't have that. So now on the gray model, I'm going to do control divide, because cosecant is the reciprocal of sine. Okay, so I'm going to do that. And we've got pi, and I'm going to say, well, I'm going to back that up because I need a fraction here also. And I need pi, I'm going to say times x. I'm going to make sure that the Inspire knows. It does already, but I'm going to make sure. So I'm going to do that, put a multiplication sign in there, and put a 6 in here. And I'm going to tab over until I get to the interval piece of it. Now, I suggest you always put in exactly what you have. Don't put in anything other than the exact one. I'm going to stop this.